In this section, we are going to discuss the differentiation of inverse trigonometric function. So let us begin with the first trigonometric function, sine inverse of x. So derivative of the inverse trig function, sine inverse of x with respect to x. So we're going to find its value. And we will be using the standard result and later a part of the lecture, when we'll be solving different kinds of problems. So we begin by assuming that sine inverse of x be equals to some variable y. Then we are going to take the sine function on both sides. So that will give us sine inverse of x will be equals to sine of y. Now sine inverse of x is simply going to give us x. So x will be equals to sine y. Let's label it as equation number 1. Now we're going to differentiate both sides with respect to x. So differentiating x with respect to x on the left hand side and differentiating sine of y with respect to x. So differentiation of x with respect to x is simply going to give us 1. Now differentiation of sine y can be found out by using the chain rule, because we are differentiating a function of y with respect to x. So we're going to assume that y is x. So that means differentiation of the sine function should give us cosine of y. But since y is not x, so we have to multiply it to the derivative of y with respect to x. So this is the chain rule. So this is going to give us, rearranging the terms, so we're going to get dy over dx equals to 1 over cosine of y. Now we are going to use the identity that sine squared y plus cosine squared y equals to 1. So from here we'll get cosine squared y equals to 1 minus sine squared y. So that gives us cosine of y equals to the positive square root of 1 minus sine squared y. So we're going to replace cosine of y with square root of 1 minus sine squared y. So that gives us differentiation of y with respect to x will be equals to 1 over square root of 1 minus sine squared y. Now we're going to use number 1 because sine of y is equals to x. So that gives us dy over dx is equals to 1 divided by square root of 1 minus x squared. So sine of y is x. So replacing sine of y with x, we're going to get 1 minus x squared. So the differentiation of the inverse sine function will be equals to 1 divided by square root of 1 minus x squared. And here the value of x will be such that it lies within the interval -1 and +1. Now we're going to find the derivative of the inverse cosine function with respect to x. So we're going to use the same method. So let cosine inverse of x be equals to some variable y. Then we take the cosine function on both sides. So that will give us cosine inverse of x will be equals to cosine of y. So cosine inverse of x will be x, which will be equals to cosine of y. Let's label this equation as number 1. Now we're going to differentiate both sides with respect to x. So differentiation of x with respect to x will be equals to differentiation of cosine of y with respect to x. So derivative of x with respect to x is equals to 1. Now derivative of cosine of y with respect to x will be done by using the chain rule. So we have derivative of the cosine function gives negative sine of y multiplied to the derivative of y with respect to x. Now rearranging, we are going to get dy over dx equals to -1 over sine of y. Now we're going to use the identity that sine squared y is equals to 1 minus cosine squared y. So sine of y will be equals to the positive square root of 1 minus cosine squared y. Substituting this value, we're going to get dy over dx is equals to negative 1 over square root of 1 minus cosine squared y. Now this was done because we have the value of cosine of y, so we can substitute cosine of y with x as given in equation number 1. So we have derivative of y. Now we're going to substitute y with cosine inverse of x. So that gives us negative 1 divided by square root of 1 minus, so cosine of y will be x, so we have x squared. So derivative of the cosine inverse function is negative 1 divided by square root of 1 minus x squared. And here the value of x is going to lie between negative 1 and positive 1. Negative 1 and 1 are both excluded. So now we are going to find out the derivative of the inverse tangent function. So let us begin by assuming that the tangent inverse of x be equals to y. Now taking the tangent function on both sides, so we're going to get tan of tangent inverse of x equals to tangent of y. So tangent of tangent inverse of x will be equals to x. So that gives us x equals to tangent of y. So let's label this as equation number 1, and the second one, x equals to tan of y, as equation number 2. Now we're going to differentiate equation number 2 both sides with respect to x. So differentiation of x with respect to x is going to be equals to 1, and derivative of the tangent function is secant squared y. Now since we're finding the differentiation of a function of y with respect to x, so we're going to use the chain rule, and that's going to give us dy over dx. So we get dy over dx equals to 1 over secant squared y. Now we're going to use the identity, the 1 plus tangent squared x is equals to secant squared x. Now since we have y, so this will become dy over dx will be equals to 1 over 1 plus tangent squared y. So on the left hand side, we're going to replace y with tangent inverse of x by using equation number 1. So we're going to get the derivative of tangent inverse of x will be equals to 1 divided by 1 plus, so we're going to use equation number 2 and substitute tangent of y with x, so that's going to give us x squared. So the derivative of the inverse tangent function is 1 over 1 plus x squared, and the value of x will be all real numbers. So now we are going to differentiate the inverse cotangent function. So let us begin by assuming that cot inverse of x be equals to y. Taking the cotangent function on both sides, so we're going to get x equals to cotangent of y. Then we're going to differentiate both sides with respect to x. So differentiation of x with respect to x is going to be equals to 1, which will be equals to differentiation of cotangent of y with respect to x. And we know that differentiation of cotangent function is negative cosec squared y times dy over dx. So that gives us dy over dx equals to negative 1 over cosec squared y. So now here we use the identity that 1 plus cot squared y equals to cosec squared y. So this will be equals to negative 1 divided by 1 plus 1 plus cot squared y. So let's label this as equation number 1, and this is equation number 2. Now on the left hand side we have dy over dx, so replacing y with cot inverse of x. So that will be equals to -1 divided by 1 plus, so we have cot squared y. So using equation number 2, so we're going to substitute cot of y with x, so that will be simply x squared. So the derivative of the inverse cotangent function is -1 divided by 1 plus x squared, and the value of x will be all real numbers. So now we're going to find the derivative of the inverse secant function. So let secant inverse of x be equals to y. Taking the secant function on both sides, so we have secant of secant inverse x equals to secant of y. So secant of secant inverse of x is going to give us x, so x will be equals to secant of y. Now secant inverse x equals to y, let's label this as equation number 1, and x equals to secant of y as equation number 2. Now we find the derivative on both sides of equation number 2 with respect to x. So derivative of x with respect to x is going to be equals to 1, and derivative of secant of y with respect to x. So 1 will be equals to, so derivative of the secant function is secant of x, secant of y times tangent of y multiplied to dy over dx. So we have applied the chain rule here. So rearranging or writing in terms of dy over dx, so we are going to get 1 divided by secant of y times tangent of y. Now here, if we look at equation number 2, we have secant of y, so that can be replaced by x. But here we also have tangent of y in the product, so we will be converting tangent of y to secant of y by using the identity that 1 plus tangent squared y equals to secant squared y. So we have 1 over secant of y times, so to find out tangent of y, so we have tangent squared y equals to secant squared y minus 1, taking the positive square root, so we're going to get square root of secant squared y minus 1. So that will be equals to 1 divided by, so secant of y, we're going to substitute with x, so we have x multiplied to the square root of x squared minus 1. And we have on the right hand side, on the left hand side we have the derivative of y, so y is substituted with secant squared x, taken from equation number 1. So that means the derivative of the inverse secant function is 1 divided by x times x squared minus 1. And the value of x will be all real numbers except numbers between -1 and +1. That's because if we look at the edges -1 or +1, so if we substitute into x squared minus 1, so that's going to get 0, and we cannot divide by 0, so we have to exclude it. Also, x equals to 0 is not allowed because we have 1 over x in the denominator, so that's again going to make the denominator 0. Now any number between -1 and 0 or any number between 0 and 1 is going to make the value inside the square root a negative, so which is not allowed. So that means we have to exclude all the values of x between -1 and +1. Other than that, it's going to be valid for all real values of x. And finally, we're going to find the derivative of the inverse cosecant function. So let cosecant inverse of x be equals to y. Let this be equation number 1. Then taking the cosecant function on both sides, so we're going to get x equals to cosecant of y. Let this be equation number 2. Then we're going to find the derivative on both sides of equation number 2 with respect to x. So derivative of x with respect to x is going to be equals to 1, and derivative of the cosecant function of cosecant of y with respect to x will be negative cosecant of y times cotangent of y multiplied to dy over dx. So writing in terms of dy over dx, so we're going to get dy over dx equals to -1 divided by cosec of y times cotangent of y. Since we have 1 plus cotangent squared of y is equals to cosecant squared of y, so that gives us -1 divided by cosecant of y times square root of cosecant squared y minus 1. So this can be obtained from this particular identity. So this is dy over dx. Now on the left hand side we have y, so we're going to substitute y with cosecant inverse of x by using equation number 1. So derivative of cosecant inverse of x will be equals to -1 divided by, so in the denominator we have cosecant of y, which is equals to x, given by equation number 2. So let's substitute with x and multiply it to the square root of cosecant squared y, so that will be x squared minus 1. So the derivative of the inverse cosecant function will be -1 divided by x multiplied to the square root of x squared minus 1, and the value of x is going to be equals to all real values except -1 and 1. I accept all the intervals, I accept all the values lying between the interval -1 and +1.